Hello friends, let's start part 2 of learning Kubernetes and how to do it with AWS. So cluster architecture. In this we will learn how to build Kubernetes cluster that runs on Amazon Web Services from first principle. The cluster we build is suitable for use when learning about managing Kubernetes for developing applications that can run. With this instruction, we are aiming to build the simplest possible cluster that can deploy to AWS. Want to deploy when mission critical application, but don't worry, there are 3 chapters in part 3 ready for production. We cover everything you need to know. Get your cluster ready for even the most demanding applications. There's an important thing as per experience that EBS volumes have to be deleted even you terminate your instances, because EBS volumes will cost you. So typical Amazon cluster will look like an outside abstraction of AWS services. Then there is a virtual VPC that you can create to protect internal VPC network, virtual private cloud for your applications, and within a VPC you can have 1 or 2 subnets. So here we have a Bastion host, an elastic load balancer, and net, all the applications management related software infra management related services, and another the actual applications related services. Bastion host is the one host where you can log in and then you can access the further services. So you cannot directly access the load balancer, it has to be through Bastion. Then we add the router which will connect the services from master node to each of these. Then we have internet gateway and other things. These are the steps to create an AWS user. Another important thing is, always when you create an AWS account, always work with IAM user, or there is another thing, IAM central user management service. IAM users, you can create multiple policies based on users, based on groups, roles and other things. Once you have logged into it, go to the identity access management there by clicking on services typing. From the sidebar view, you only just set up a new account. There won't be any users. The root account doesn't count as a user. Start the process setting up new user. Click on add user, choosing the username. Click both boxes to enable programmatic, so you can use the command line client and management console. You can log in through web console. So this is the typical dashboard. You can go, you have the details, permissions, you can create a strong auto generated password, next permissions. This is the typical permission, job functions, type, attachment, description, policy name. You can create different policies and then you can attach the policies. Manage policy, IAM user, change password, administrative access. First you need to set up a SH key pair thing. You can create to SH thing, you can create an RSA key with your organization or personal email ID, which will create a public private RSA key. You can save the keep the private key, don't share the private key anywhere, just share the public key. This is the fingerprint. From this, choose import key pair, bring in the dialog. You can upload your key pair shown the following screenshots. Now you can upload your key pair. Choose the name that will identify your key pair. Next is preparing for VPC, virtual private cloud. Virtual private allows you to a private network that is isolated from all other users of EC2 and the internet that we can launch instances onto. Which ID will be unique to come, so I am going to set a shell variable used to refer it. Kubernetes names your instances based on the internal DNS host and AWS assigned to them. if we enable DNS support in the VPC, then we will not be able to resolve these hostname when using DNS server provided inside the as follows. Kubernetes make extensive AWS resource stack so to knows which resource it can use and which resources are managed by Kubernetes. The keys for these stacks is Kubernetes IO cluster, cluster name might be shared between several distinct clusters. We use shared value. This Kubernetes can but won't either ever remove them from your account. We would use this for resources such as VPC, where your life cycle is fully managed by have a tag value of owned and may be deleted by Kubernetes if they are no longer. Kubernetes typically create these tags automatically when it creates sources such as instances in an auto scaling group, EBS volumes or load balances. I like to name the cluster I create the famous AWS EC2 create tags, resources, VPC ID tags, key name value, hopper. When we create our VPC, our main route table was automatically cleared. We'll use this for routing our private subnet. Let's grab the ID to use later. Now we will add a second route table to manage routing of the public subnets into our VPC. Public route table ID AWS EC2 create route table VPC ID query route table minus output text. Now we'll give the route table name so we can keep track of them later. Now we will be setting up the Bastion system using these commands. I am allowing ingress from the CIDR range, but if your internet connection is stable, you might want to limit to just your own IP addresses. Forward traffic from workstation to a powered network just by using. However, you can make accessing server and much more convenient by using the SH shuttle tool. Install it on Mac OS Homebrew as follows. Transparently proxy traffic to the instance inside the private. We can run the following. Firstly, pass the SSH login details of our Ubuntu CIDR. Whether this setup is working, SSH Ubuntu. To this end, I have collated a set of minimal IAM policies that we will allow our cluster to function correctly without giving access permissions away. You can view this policy at this document with a brief description. Curl command Kubernetes master setup instance profile. To make use of the integration of the AWS cloud, we need to set up IAM instance profiles. An instance profile is a way for Kubernetes software to authenticate with the AWS API and for us to assign fine-grained permission to actions that Kubernetes can take. Now, so finally what we are doing is we can set up IAM policies for Kubernetes. Earlier we set up IAM policies for users and onboarding or access to Bastion system or infra services and application services. We will create an AMI or Amazon machine image that we can use to launch the nodes on our cluster. We need to be able to access this instance from a Bastion host in order to log and install software. We just need a T2 micro instance. Here you don't need a very powerful to install packages shown in the following command. We need a name tag. We can identify instead later if we need as follows. Kubernetes can work with number of container runtimes, but Docker is still the most widely used. we need to allow traffic from Bastion server to access the API server. As we discussed in the previous videos, that Kubernetes have a API server. So from the Bastion server, we need to put a rule to access to the Kubernetes API server using this command. We haven't already installed kubectl on a workstation. Turn back to chapter, start your engine. SCP Ubuntu kube config. Already with cluster config, then you may wish to merge the config of the new cluster. If you have any connecting, check the access status still, and then you have correctly allowed access from the Bastion host to Kubernetes master security group. You may have noticed that when running kubectl, get the node status is node. This means because the cluster we have boosted is missing one essential, a network infrastructure that will allow the pods running on our cluster to communicate with other. A network model for Kubernetes is somewhat different from that of standard Docker install. There are many implementations of network infrastructure. Each pod is assigned its own IP address. Each pod can communicate with any of the other pods in the cluster without net, not with extending additional security work. The internal network that the software running inside it sees is identical to the pod network seen by other pods in the cluster. This networking is much simpler than Docker's standard networking scheme of mapping internal ports. However, require one integration between the network intelligence and Kubernetes. Manages this integration through interface called container network interface. Simpler to replace plugin to each of the node with a Kubernetes daemon set. If you want to learn Kubernetes cluster net, recommended reading the comprehensive documentation on this one. Deploy CNI plugin VPC. To monitor the network that is being installed, start by running the kubectl-kube daemon describe pods AWS node. Network has been set up correctly. Looking at the node status again, ready state. Now we are going to create new security for worker nodes. Access to worker node via Bastion host. We want to allow the kubelet and other processes running on the worker node to be able to connect to the API server on the master node. Authorize security group this. Since the kube DNS adds on many may run on the master, it allows traffic from the node security group. The master node to be able to connect to the APIs that are exposed by the kubelet in order to stream logs and other matrices. To allow any pod on any node to be able to connect to any other pod. We do this by using this protocol, this thing. In order to have the worker register themselves with the master when they start up, we will create a user data script. This script is run on the first occasion that the node configuration system then runs kube adm join. Set exio pipe fail hostname set hostname. First we create a launch configuration using the file. This take like a template of the configuration that the auto scaling group will use to launch our worker. Similar to that, we would have paused to EC2 run instance. Once we have created the launch configuration, we can create an auto scaling group as follows. If your node is start but doesn't join the cluster of people, let's try logging into the node and looking at the cloud init log. Configuration you have made through the cluster. Apply -f kube demo.yaml. This manifest deploys simple web application as a service to expose that using a load balancer. We can view the public DNS name of the load balancer by using the get service command. Once you have public address on the load, you will need to wait for the few moments before the address start to resolve. By now you should have fully functional Kubernetes cluster that you can use to experiment with and explore Kubernetes more fully. There are many tools that can automate assist you in task of building managing Kubernetes cluster. We will look at the tools and procedure you can adopt to manage deployment tools. Manage changes in your application. In this chapter, we have in the previous chapter we have learned how to run the Kubernetes set up Kubernetes cluster in AWS. But here we are managing the changes in our application that is already running in AWS cluster. We will learn how to ensure that batch tasks are successfully completed. We will learn how to run cron jobs at scheduled interval. We'll also look at how we can launch pods in different ways with Kubernetes depending on the workloads we are running. By design, pods are not intended to be durable. As we have discussed, there is a whole raft of conditions that can be cause the life of a pod to. They include failure of an underlying node, perhaps caused by some such as hardware failure or perhaps by design. For example, in a cluster utilizing spot priced instances can be terminated